Now we will start studying about our topic that has been mentioned over here as Master NLP in 60 minutes, Natural Language Processing for Beginners. Let us move to the next part where we will study about the objectives of the course. By the end of this course, viewers will understand what NLP is and its real-world applications. Learn the basics of text pre-processing and tokenization. Work with popular NLP libraries, NLTK, Spacey, Hugging Face. Explore key NLP techniques like named entity recognition, sentiment analysis, and text classification. Build a simple NLP project using Python. Let us move to the next part where we will study about the course structure. In the first part, you will learn about Introduction to NLP, under which you will learn what is NLP, how NLP helps machines understand human language and real-world applications. In the next part, explore setting up the NLP environment, under which you will understand installing required Python libraries, importing necessary packages, and downloading necessary datasets, models. In the third part, learn about text pre-processing, under which you will study tokenization and removing stop words. In the fourth part, gain knowledge on named entity recognition (NER), under which you will learn identifying entities in text and explanation of entity labels. Next, gain proficiency on sentiment analysis, under which you will understand sentiment analysis using Hugging Face and sentiment analysis for social media monitoring. In the next part, explore text classification, under which you will learn classifying movie reviews using Hugging Face and how machine learning models classify text. Next, gain hands-on experience on building a simple NLP project, under which you will understand in details about the project, new sentiment analyzer, and demonstration example. Finally, you will learn about the conclusion. You should be interested in exploring NLP for research projects, language modeling, and text analysis. This course is specially designed and tailored for those seeking to build a career in natural language processing by learning how machines interpret and generate human language through AI and deep learning techniques. So that is everything that can be said as per the mentioned details. Now we will move towards the main discussion part. As per this slide is concerned, here we will be discussing about Introduction to NLP. Let us first go through the details that has been mentioned over here and then we will discuss it. What is NLP? Natural Language Processing (NLP) is a branch of artificial intelligence (AI) that enables machines to understand, interpret, and respond to human language. NLP combines linguistics and machine learning to analyze text and speech. How NLP helps machines understand human language? Breaks down human language into tokens, words, phrases, and assigns meaning. Identifies syntax, structure, and semantics, meaning to understand context. Uses machine learning models to improve understanding and response. So from this part, we can understand that natural language processing or NLP is a branch of artificial intelligence (AI) that enables machines to understand, interpret, and respond to human language. NLP combines principles from linguistics and machine learning to analyze both text and speech, making it possible for machines to process and generate human language more accurately. NLP helps machines understand human language by breaking down sentences into smaller components called tokens, like words or phrases, and assigning meaning to them. It identifies syntax, the structure of language, and semantics, the meaning of language, to understand the context of communication. Machine learning models are used to improve the machine's ability to recognize patterns and respond intelligently based on the understanding. The provided image shows a Venn diagram representing the relationship between natural language processing (NLP), artificial intelligence (AI), machine learning, deep learning, computer science, and linguistics. NLP is highlighted as a part of both artificial intelligence and linguistics, indicating that it combines computational techniques and language understanding. The largest circle represents artificial intelligence, which includes machine learning, a smaller circle with AI. Deep learning is shown as a subset of machine learning, indicating that it is a specialized technique within machine learning itself. NLP overlaps with machine learning and deep learning, showing that these techniques are used to enhance language understanding. The diagram also shows that NLP draws from both computer science and linguistics, highlighting the interdisciplinary nature of NLP. So this can be said as per the details mentioned over here. Now we will move on to the next particular slide. So in this particular slide, we will be learning about real-world applications. We will first go through the details that has been mentioned over here and then discuss it. Chatbots and virtual assistants. Tools like Siri, Alexa, and ChatGPT use NLP to understand user queries and generate human-like responses. Sentiment analysis. Analyzes text, example social media, to determine emotional tone, positive, negative, neutral. Example, monitoring customer feedback for brand sentiment. Machine translation. Tools like Google Translate use NLP to translate text between different languages while maintaining context. Text summarization. Automatically generates a summary of long texts. Example, news articles. Example, news aggregators providing quick summaries. Named entity recognition (NER) identifies key identities, names, dates, locations in text. Example, extracting important details from legal or medical documents. So from these details we get to understand that natural language processing or NLP has several real-world applications that make human-computer interaction more efficient and natural. Chatbots and virtual assistants like Siri, Alexa, and ChatGPT use NLP to understand user queries and generate human-like responses, improving customer service and user experience. Sentiment analysis analyzes text from sources like social media to determine emotional tone, positive, negative, or neutral, helping businesses monitor customer feedback and brand sentiment. Machine translation tools like Google Translate use NLP to translate text between different languages while maintaining context and accuracy. Text summarization generates a concise summary of long texts, such as news articles, enabling quick access to key information. Named entity recognition, also known as NER, identifies important entities like names, dates, and locations in text, which is useful in extracting key details from legal or medical documents. These applications highlight how NLP enhances language understanding and processing in various fields. The provided image shows various applications of natural language processing arranged around a central processor icon. The key applications include chatbots, email filtering, language translation, sentiment analysis, predictive text, text summarization, smart assistants, and automated evaluation systems AES. Each application highlights how NLP processes and interprets human language to automate tasks and improve user experience. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So as per the slide is concerned, here we will be discussing about setting up the NLP environment. Let us first go through the details that has been mentioned over here and then we will discuss it. Installing required Python libraries. Use pip to install the necessary NLP libraries. NLTK, Natural Language Toolkit for text processing. Spacy, fast and accurate NLP library for tokenization, parsing and entity recognition. Transformers, library for pre-trained language models, example BERT, GPT. Command, Python code, pip install NLTK Spacy transformers. Importing necessary packages. Import key libraries into your Python environment. Python code, import NLTK, import Spacy, from transformers, import pipeline. So from this part, we can say that to set up an NLP environment, you'll have to install key Python libraries like NLTK, Spacy and Transformer using pip.nltk, Natural Language Toolkit, which is widely used for text processing tasks like tokenization, stemming and classification. Spacy is known for its speed and accuracy in tokenization, parsing and named entity recognition (NER). Transformers provides pre-trained language models like BERT and GPT, which allow for advanced language understanding and generation. Installing these libraries sets up a solid foundation for building NLP-based applications. In the provided Python code, the pip install NLTK Spacy transformers command installs the required libraries. The import NLTK statement imports the NLTK library for text processing tasks. Import Spacy loads the Spacy library for natural language processing, and from transformers import pipeline imports the pipeline function from the transformers library, which allows easy access to pre-trained models for tasks like text generation and classification. So this can be said as per the details mentioned over here. Now let us move to the next particular slide. So in this particular slide, we will be discussing in details about downloading necessary datasets, models. Let me first go through the details that has been mentioned over here and then we will discuss it. 1. NLTK, download tokenizer and stop words. Python code, nltk.download punct, nltk.download stop words. 2. Spacy, download the English language model. Python code, spacy.cli.download encodeweb sm. Punct, pre-trained tokenizer for breaking text into sentences and words. Stop words, commonly used words, example the and, for filtering. encodeweb sm, Spacy's small English language model for parsing and NER. So from these details we get to understand that to work with natural language processing effectively, you will have to download necessary datasets and models for libraries like NLTK and Spacy. NLTK provides the punct tokenizer for splitting text into sentences and words, and the stop words dataset, which includes common words like the and that are often filtered out in text processing. Spacy requires the encodeweb sm model, which is a small but effective English language model for tasks like tokenization, parsing and named entity recognition (NER). Downloading this resources ensures that the libraries function correctly for NLP tasks. In the provided Python code, nltk.download punct downloads the punct tokenizer and nltk.download stopwords downloads the stopwords dataset. On the other hand, the Python command spacey.cli.download encowebsm downloads the Spacey English model, which enables parsing and entity recognition capabilities. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. As per this slide is concerned, here we will be discussing about text pre-processing. Let us first go through the details that has been mentioned over here and then we will discuss it. Text pre-processing is the process of cleaning and preparing text data for analysis. It improves the accuracy of NLP models by reducing noise and focusing on meaningful data. Key pre-processing steps include tokenization and stopword removal. Tokenization. Tokenization is the process of splitting text into smaller units. Words. Individual tokens representing meaningful units. Sentences. Group of words forming a logical statement. Example, Python code. From nltk.tokenize, import word tokenize, send tokenize. Text is equals to natural language processing is amazing. Let's learn it. Words is equals to word tokenize text. Sentences is equals to send tokenize text. Print words hash natural language processing is amazing exclamation. Let's learn it. Print sentences hash natural language processing is amazing. Let's learn it. So from this part we get to understand that text pre-processing is a crucial step in NLP that involves cleaning and preparing text data to improve the accuracy of models by reducing noise and focusing on meaningful information. It includes various steps such as tokenization and stopword removal. Tokenization breaks down text into smaller units like words or sentences, which allows the model to analyze the structure and meaning of the text more effectively. For example, tokenizing a sentence into words helps identify individual terms, while sentence tokenization helps understand the logical flow of statements. In the provided Python code, word tokenized text splits the input text into individual words, and sent tokenized text splits the text into sentences. The sample text natural language processing is amazing. Let's learn it is tokenized into words like natural language processing is amazing exclamation. Let us learn it full stop, and into sentences like natural language processing is amazing. Let's learn it. So this can be said as per the details mentioned over here. Now let us move to the next part. So here in this mentioned part, we will be discussing about removing stopwords. Let's take a look at the details that has been mentioned over here and then discuss it. Stopwords are common words. Example is the and that do not carry significant meaning. Removing stopwords helps to reduce noise and improve model efficiency. Example, Python code. From nltk.corpus, import stopwords. Stopwords is equals to set stopwords.words English. Filtered words is equals to w for w in words if w.lower, not in stopwords. Print filtered words hash natural language processing amazing exclamation. Let us learn full stop. Stopwords.words English. loads a list of common stop words in English. Lower converts text to lowercase for consistency. Filtered words retains only meaningful words. So from these details we get to understand that removing stop words is an essential step in NLP that involves eliminating common words like is, the, and that do not carry significant meaning and can reduce the model's efficiency. By removing stop words, you can focus on meaningful content, which improves the performance of the model by reducing the dimensionality of the data. Words like conjunctions, prepositions, and articles are usually treated as stop words because they contribute less to the actual context or sentiment of the text. In the provided Python code, stopwords.words English loads a list of common stop words in English. The list comprehension W for W in words if W.lower not in stop words filters out the stop words by converting each word to lowercase using lower for consistency and checking if it is not present in the stop words list. The output retains only meaningful words like natural, language, processing, amazing, exclamation, let, s, learn, full stop. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So as per this slide is concerned, here we will be discussing about named entity recognition, NER. Let us first go through the details that has been mentioned over here and then we will discuss it. NER is the process of identifying and classifying entities in text. Entities can include people, names of individuals, locations, geographic places like cities and countries, dates, specific dates or time references, organizations, company and institution names. Identifying entities in text. Python code. Import spacey. NLP is equals to spacey.load encode web sm. Doc is equals to NLP. Elon Musk is the CEO of Tesla and SpaceX based in the USA. For ENT in doc.ents, print ent.text hyphen ent.label. So from these details we get to understand that named entity recognition NER is the process of identifying and classifying entities such as names of people, geographic locations, dates, and organizations within a text. NER helps in extracting structured information from unstructured data, which improves the understanding of the context and relationships in the text. For instance, recognizing Elon Musk as a person or Tesla as an organization enables better insights and structured analysis of text. In the provided Python code, the spacey library is used for NER. The spacey.load encode web sm function loads spaceys small English model. The NLP object processes the input text. Elon Musk is the CEO of Tesla and SpaceX based in the USA. And the loop for ENT in doc.ents extracts entities from the text. The ent.text provides the entity's text while ent.label classifies the type of entity. Example, person, organization or group. The output will identify entities like Elon Musk is person, Tesla is organization and USA is group. The provided image shows a table titled Explanation of Common Entity Labels, which outlines common entity labels used in named entity recognition NER. It includes 4 key labels: person, representing a person's name and such as Elon Musk; org, representing an organization such as Tesla and SpaceX. GPE, representing geopolitical entities like countries or cities, such as USA and Canada. And date, representing dates or times such as July 4, 2023. These labels help NER model identify and categorize important information within text, enabling more effective data extraction and analysis for tasks like text classification and information retrieval. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. In this particular slide, we will be discussing about sentiment analysis. Let us first go through the details that has been mentioned over here and then we will discuss it. Sentiment analysis is the process of determining the emotional tone behind a piece of text. It classifies text as positive, negative, or neutral based on the context. Used for social media monitoring, customer feedback analysis, brand perception tracking. Example, sentiment analysis using Hugging Face. Use Hugging Face's pipeline for quick sentiment classification. Pipeline sentiment analysis loads a pre-trained sentiment analysis model. The model classifies the input text as positive with a high confidence score 0.9998. So from this part, we can understand that sentiment analysis is the process of determining the emotional tone behind a piece of text, classifying it as positive, negative, or neutral. It helps businesses analyze customer feedback, monitor social media trends, and track brand perception to understand public opinion and improve customer satisfaction. By using machine learning models, sentiment analysis can identify patterns in text and predict how people feel about a product, service, or event, enabling businesses to make data-driven decisions. In the provided Python code, the transformers library from Hugging Face is used to create a sentiment analysis pipeline with pipeline sentiment analysis, which loads a pre-trained model for sentiment classification. The input text "I love NLP, it's so exciting" is processed by the model, which returns a result of label positive score 0.9998. This indicates that the text is classified as positive with a confidence score of 99.98%, demonstrating that the model strongly associates the input with positive sentiment. This approach is widely used in social media monitoring, customer service, and product reviews to gauge public perception automatically. So this can be said as per the details mentioned over here. Now let us move to the next part. Here in this mentioned part, we will be learning about sentiment analysis for social media monitoring. Let's take a look at the details that has been mentioned over here and then discuss it. Businesses use sentiment analysis for social media monitoring to track and understand customer opinions, trends, and brand perception in real time. By analyzing posts, comments, and reviews on platforms like Twitter, Facebook, and Instagram, businesses can identify whether the sentiment around their products or services is positive, negative, or neutral. This allows them to respond quickly to negative feedback, address customer concerns, and engage with positive comments to strengthen customer relationships. Sentiment analysis also helps in crisis management by detecting negative sentiment spikes early, enabling businesses to take corrective action before issues escalate. Additionally, companies use sentiment data to evaluate the success of marketing campaigns and improve product offerings based on customer feedback. So from this part, we can say that sentiment analysis is the process of determining the emotional tone behind a piece of text, classifying it as positive, negative, or neutral. It is widely used in social media monitoring to understand customer opinions, track brand perception, and evaluate customer feedback in real time. Businesses can analyze posts, comments, and reviews on platforms like Twitter and Facebook to detect sentiment trends and respond to issues quickly. It helps in identifying customer satisfaction levels, improving product offerings, and addressing negative feedback to enhance customer relationships. Additionally, sentiment analysis assists in crisis management by spotting negative sentiment spikes early and taking corrective action before problems escalate. The first image shows the basic steps involved in sentiment analysis on social media. It starts with user-generated content on social media platforms, followed by data aggregation and pre-processing to clean and structure the data. The pre-processed data is then converted into text embeddings, which are analyzed by a classification model to determine whether the sentiment is positive, neutral, or negative. The second image presents examples of sentiment classification results. It shows three categories: positive, neutral, and negative. Positive sentiment includes favorable feedback like great food for an affordable price. Neutral sentiment reflects balanced feedback like food was good. And negative sentiment shows dissatisfaction such as horrible services, the food tastes really bad. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So as per this slide is concerned, here we will be discussing in details about text classification. Let me first go through the details that has been mentioned over here and then we will discuss it. Text classification is the process of assigning categories or labels to text based on its content. Machine learning models are trained on labeled text data to identify patterns and classify new text. Used for spam detection in emails, news categorization, sentiment analysis, product review classification. Example, classifying movie debuts using Hugging Face. Use Hugging Face's pipeline to classify text with a pre-trained model. Pipeline text classification loads a pre-trained text classification model. The model identifies the review as positive with a high confidence score 0.996. So from these details we get to understand that text classification is the process of assigning categories or labels to text data based on its content using machine learning models. These models are trained on labeled text data to identify patterns and apply them to new text for classification. It is widely used for various applications such as spam detection in emails, news categorization, sentiment analysis, and product review classification. Text classification allows businesses to automate content organization, improve search relevance, and gain insights from customer feedback. Pre-trained models like those available in Hugging Face's pipeline enable quick and accurate classification of text, helping to identify sentiment or other attributes with high confidence. The provided Python code shows an example of text classification using the Hugging Face library. The code imports the pipeline from the transformers library and initializes a text classification pipeline using pipeline text classification. The model then processes the input text. This movie was fantastic. The acting was brilliant, and predicts the sentiment as positive with a confidence score of 0.996. The result confirms that the model successfully identified the sentiment of the text with high accuracy. So this can be set as per the details mentioned over here. Now let us move to the next particular slide. So in this particular slide, we will be learning about how machine learning models classify text. Let me first go through the details that has been mentioned over here and then we will discuss it. Training phase. Model is trained on large datasets with labeled text. It learns patterns based on word usage and structure. Prediction phase. Input text is tokenized and converted into numerical format. The model assigns a probability to each label and selects the highest one. Fine-tuning. Models can be fine-tuned for domain-specific classification. Example, legal or medical text. So from this part, we can say that machine learning models classify text by training or labeled datasets to identify patterns based on word usage and structure. During the training phase, the model is exposed to large amounts of labeled data, learning the relationship between input text and output labels. In the prediction phase, the input text is processed by tokenizing and converting it into numerical format, which is also known as features, which the model uses to assign a probability to each possible label and select the one with the highest probability. Fine-tuning allows the model to adapt to specific domains such as legal or medical text, improving accuracy for specified tasks. The provided image illustrates the process of text classification using machine learning. In part A, training, the input text is processed by a feature extractor, which converts it into numerical features. These features, along with the corresponding label, are used to train the machine learning algorithm. In part B, prediction, the input text is processed in the same way to extract features, which are then passed into the trained classifier model to predict the label. This demonstrates how a model learns from data and then applies the learning process to classify new text inputs. So this is everything that can be said as per the details mentioned over here. Now let us move to the next discussion part. So here in this mentioned part, we will be discussing about building a simple NLP project. Let us first go through the details that has been mentioned over here and then we will discuss it. Project, News Sentiment Analyzer. Goal, build a sentiment analyzer for news headlines. Input, a news headline entered by the user. Output, model predicts if the sentiment is positive, negative or neutral. Tools, Hugging Faces, pipeline for sentiment analysis. Code example, create a Python function to analyze the sentiment of a news headline. Python code, from transformers import pipeline. Def, analyze news sentiment news text. Sentiment pipeline is equals to pipeline sentiment analysis. Result is equals to sentiment pipeline news a text. Return result 0 label. Headline is equals to input, enter a news headline. Print sentiment, analyze news sentiment headline. So from these details we get to understand that a simple NLP project like a news sentiment analyzer involves building a sentiment analyzer for news headlines using Hugging Faces pipeline for sentiment analysis. The goal is to input a news headline and predict whether the sentiment is positive, negative or neutral. The pipeline method loads a pre-trained sentiment analysis model that processes the input text, analyzes it and returns the predicted sentiment label with a confidence score. This type of project helps understand how to implement sentiment analysis using pre-trained models and how to process real-world text data effectively. In the provided Python code, the analyze news sentiment function takes a news headline as input and uses the pipeline from the transformers library to analyze its sentiment. The pipeline sentiment analysis loads a pre-trained sentiment analysis model. The model processes the input and returns the sentiment label, which is either positive, negative, or neutral, with a corresponding confidence score. The result is extracted using result 0 label to display the sentiment prediction. However, there is a typo in news a text, which should be corrected to news text to avoid an error when running the code. This can be said as per the details mentioned over here. Now let us move to the next part. So in this mentioned part, we will be studying about the demonstration example. Let's take a look at the details that has been mentioned over here and then we will discuss it. Input: stock market hits record high after positive earnings report. Output: sentiment positive. Input: major earthquake causes severe damage in the city. Output: sentiment negative. So from this part, we can say that the demonstration example shows how a sentiment analysis model built using Hugging Face's pipeline function processes users' inputted news headlines and assigns a sentiment label, which is either positive, negative, or neutral. The pipeline sentiment analysis function loads a pre-trained model that evaluates the sentiment of the input text based on the language used. The model analyzes the input text, computes the sentiment score, and returns the label with the highest confidence score. This project highlights the capability of pre-trained models to handle real-world text classification tasks efficiently without the need for extensive training process. The provided examples demonstrate the sentiment classification results of the model. In the first example, the input stock market hits record high after positive earnings report is classified as positive. This is because the text contains positive terms like record high and positive earnings, which are typically associated with financial success and positive outcomes. In the second example, the input major earthquake causes severe damage in the city is classified as negative. The terms earthquake and severe damage are negative indicators, leading the model to assign a negative sentiment. So this is everything that can be said as per the details mentioned over here. Now we will move on to the next discussion part. So in this particular slide, we will be studying about the conclusion. Let me first go through the details that has been mentioned over here and then we will discuss it. In this session, you have learned the fundamentals of natural language processing (NLP), including text pre-processing, sentiment analysis, named entity recognition (NER), and text classification. You also built a simple sentiment analyzer using Hugging Face's pipeline. Moving forward, you can deepen your understanding by exploring advanced transformer models like BERT, GPT-3, and Llama for more sophisticated language understanding and generation. Additionally, you can experiment with AI-driven text generation and even try to train your own custom NLP model to solve specific business or research challenges. Keep practicing and experimenting with real-world datasets to strengthen your NLP skills. So from this part, we can conclude that the session covered the fundamentals of natural language processing, including text pre-processing, sentiment analysis, named entity recognition, and text classification. A simple sentiment analyzer was built using Hugging Face's pipeline, demonstrating how pre-trained models can classify text effectively. Moving forward, exploring advanced transformer models like BERT, GPT-3, and Llama can enhance language understanding and generation. Experimenting with AI-driven text generation and training custom NLP models can help tackle specific business or research challenges. Practicing with real-world datasets will further strengthen the overall NLP skills. So this is everything that can be said as per the mentioned details.